Getting to cut 15 9-pin headers for your Williams 3 through 7 MPU and driver board. An old 12-pin Molex connector and some 240 grit sandpaper work well to remove alkaline corrosion. A reading when there is a short between 5 volts and ground on the board. I'm working on the driver board now for a Black Knight, and I've replaced all the headers all the way around. If you send your board to a repair guy, he needs to replace all these headers because the OEM headers are crap by now. And this board, if I use diode check between black on pin 7, or no, I'm sorry, red on pin 7 and black on pin 14 of any chip, it shows a short of 0.6, so something on this board is shorted. And so I brought it over to the bench, put it in the bright light, and we definitely have a candidate there. And a reading once that short is removed. These 4 original transistors were on an alkaline drip. I am finally finished with this darn driver board. It had a total of 4 there. Those were corroded, and then there was an additional tip 102 and its pre-driver that were blown up, which backfed and blew up the 7408 with a 2 on top of it, which backfed and blew up the 6821 there. That was at U5. And so one of the things that I do when I'm working on Williams 3 through 7 boards is, if there's any problems at all, you got to go back and start marking ICs, because it's ridiculous that they didn't put any U numbers or any kind of silk screen on these boards at all. So to save yourself a lot of frustration, just go back and mark the darn things. So I've replaced the 5-volt filter cap on both the CPU and on the CPU here and on the driver board. I replaced all 12.156 headers on the driver board, plus both sides of the 40-pin interconnect, all 6 headers on the CPU board, installed a 5101 NV RAM, added a blanking indication, the lower LED, big LED, and the label. There was some corrosion, so I cleaned it up. That 7400 was corroded. It had to come out with its, these are called bypass caps. They tamp down the high frequency noise that's created on the 5-volt bus by the opening and closing of the gates internally to these integrated circuits. And every IC on the board is going to have one of those bypass caps. Let's see, I think that's it. Let's power it up. Let me show you what it looks like when you power it on. I've had it powered on, and since I've got NV RAM, the displays will alternate between the high score to date and the last score recorded. And the lamp matrix is fully operational, but let's get into test now. On system 3 through 7, well, let me say 4 through 7 because 3 is an oddball, but you first put the auto manual in the down position, as indicated here, and then you press the advance button. And when I do that now, we're going to start display test. And I release the auto manual button, so it's in its up position, which allows automatic advancement of the diagnostics. And on system 7, this is a Black Knight CPU. The next test is sound, so I'm going to press the advance button, and it will automatically go through the sound circuits on system 7. Now there's 7 of them shown there, even though the soundboard interface only accommodates 5. The next test is lamp test. Nice. And then we'll hop on over here to solenoid test, and you'll see solenoid 16 is lit up. That's the coin lockout solenoid. It's totally normal. The solenoids on this tester don't go in what would seemingly be logical order, because that's the way Williams drove them. And I wanted the LEDs on the tester to match what is on, or the layout of the LEDs to match the tip 102s, etc. on the board. Looks like I've pressed a button inadvertently here. I had my six digit versus 7-digit display button pressed. So now it's reflecting the correct coil numbers as it goes on. You saw 16 flash there, and it will do that after the first time. After it extinguishes the coin lockout solenoid, it will turn it on and then off again. So one more time through this. Sorry, I gotta watch this closer so I don't miss anything. Some of these solenoids are driven for different lengths of time, so you can see that one might be a little dimmer than the other. That is totally normal. First, I didn't think it was normal, so I started changing tip 102s quite some time ago. And let's drive them from the switches. And I found out that's just the way the CPU drives it. I could put a scope on there and figure that out, but I'm truly not that interested in it. Let's go to switch test. And Black Knight has 46 switches, so going across the diagonal as I can here, up to 46. I got to do something to pick up row 7 and row 8. So I have done that, proving that the switch matrix is fully operational. So I can advance through these diagnostics by pressing the advance button. I'm going to go to 18 and it shows 30. And I am going to reduce that down to 0, which places the game on free play. And then if I just hold down the button and scroll through all of those, it reboots. We've got our displays operational again. And the lamp matrix is operational again. Weird on Black Knight, it doesn't turn off the coin lockout. Oh wait, it does turn off the coin lockout. It does not turn it off, it's still on, so coins are locked out. So we are good to go. Thank you so much for sending this. I already finished the power supply. Sorry if I'm giving you vertigo. It's here. This darn thing had a shorted bridge rectifier, 2 shorted fuses, so I've taken care of that. New headers all the way around, and new capacitors. The big 5-volt filter cap, since the added Great Plains Electronics is no longer around to make the desired 18,000 microfarad axial cap, we end up using these radials and figure a way to connect those in. There's a 100 microfarad 100 volt, 1000 microfarad 25. There's a 47 and a 47 and 100 microfarad there, and a 330 microfarad there. And this one's tested out just fine. This has been modified. This is an early, or I guess a late System 7 power supply, and it may have even overflowed into System 9, but this area down here where the GI comes in has been modified several times, and this is probably the best configuration for it.